Okay, students, this is going to start your Unit 8, and we are going to actually start with a review of solving trig equations. So I need you to make sure that you refresh yourself on your special right triangles, radian measures, and just thinking about how we're going to be able to find this angle that makes the equation true. All right, let me get past these announcements. So our goal is to solve trig equations, and we are in your Unit 8 packet on page 2, and we're starting with problem number 4. Now, this is showing this equation in factored form, and anytime you have a product of two factors equal to 0. The only way this is true is if one of those factors is 0. So what we're going to use is the zero product property, and we're going to set each of these factors equal to 0 because we see their product is equal to 0. Okay, let me just get rid of this so I can make some space here. All right, so let's go ahead and isolate the trig function cosine of theta. That's equal to 1. 2 sine theta equals -1, and sine theta equals -1/2. Okay, so let's focus on the first equation, cosine theta equals 1. Let's think of our unit circle. That looks more like a unit oval. Cosine of an angle is 1. So that is going to be right here at 0 radians. So we can say, okay, theta is 0 plus 2 pi k, where k is an element of the integers. Because, of course, if I make a full rotation to the right or to the left, I would get back at that exact same spot. You do not need to write the 0 plus, so if we want, we can just go ahead and say theta equals 2 pi k, where k is an element of the integers. So that's part of our solutions. Now we need to look at sine of theta equals -1/2. So we want to, again, let's think about where is sine of an angle negative. It's down here in the third and fourth quadrant. And now we're thinking, what special right triangle has a leg length of 1/2? So we have pi over 6 and pi over 3. Here's your 1/2, your smallest side. Here's your middle length. And here's the hypotenuse, which is the longest leg, or longest side, rather. Okay, sine of what angle is a half? Let's just think about the 1/2. And of course, it's the opposite. So it's going to be this as my reference angle. The reference angle is pi over 6. Okay, so being that is a -1/2, we're going to have to be here and here. We know this is 6/6 pi, and this should be a review for most of us, but if we're a little rusty, we'll just make sure. So this is 7/6 pi, and then all the way here would be 12/6 pi, right? Because that's 2 pi. So this is 11/6 pi. Those are the two locations that would make this true. So we say, okay, theta is 7/6 pi plus 2 pi k. Because again, I can get all the way back around with a full rotation. And then theta is also 11/6 pi plus that full rotation. And we always say where k is an element of the integers. So infinite solutions, and we also see different locations for these solutions based on those two smaller equations that we solved. All right, let's take a look at page 2, number 6. Now in this case, this one is not factored, and we look like we're a little bit stuck here. So we have, and don't worry about these asterisks. So cosine squared of theta, which just as a refresher, that's the same thing as saying cosine of theta squared. Okay, that's the same. Plus 2 of cosine theta, and that equals 0. So I always do try to see, can I factor this? And I see that they share a factor of cosine theta. So I'm going to pull that out. Cosine theta times what is cosine squared theta? That's another cosine theta. Plus cosine theta times what is 2 cosine theta? That is 2. All right, same thing, ZPP. We have a factor times another factor equal to 0. So we can say cosine of theta is 0. And we can say cosine theta plus 2 equals 0. And now our job is to solve for theta. Find out what angle measure makes these true. So cosine of theta is 0. Where do we have that value? Let's see. So we have that up here and here. Because remember, this ordered pair is 0, 1 and 0, -1. This value is pi over 2, and this is 3/2 pi. So I'm going to say for this one, theta is pi over 2. And actually, if I just add half of a rotation, I can get to all the points. Okay, so we're going to say 1/2 pi plus pi k, where k is an element of the integers. Notice I didn't write 2 pi k. We could have done that, but then we'd have to have a separate one for this 3/2 pi. This will actually encompass all the solutions at both of these locations for any amount of rotations. Okay, this one here, cosine theta equals -2. So let's think about, where is the x coordinate -2? Nowhere. The lowest value is -1. So in this case, there's no solution for this small piece here. There's still solutions for this equation, but in this second piece that we did, there is no value of theta to make that true. Okay, so what you're going to do now is you are going to stay on page 4 and you're going to complete these 5 problems. And these should be a review. That doesn't mean everything is, perfectly solid. Please make sure that you have your special right triangles. So we have our pi over 4, 90, or pi over 2. And that would be our radical 2 over 2, radical 2 over 2. Of course, we have congruent legs there. And then the one we just did as well, if we have pi over 6, that's a half. Pi over 3 is radical 3 over 2. And of course, 1 is our hypotenuse. So we want to remember that. We also want to remember that cosine theta is the x-coordinate, sine theta is the y-coordinate. These are just little refreshers. Tangent of theta is the same as sine of theta divided by cosine of theta. Okay. And then, let's throw a little SOHCAHTOA on here too, just in case. Okay, so here is your little refresher guide. So write down whatever you need to. I want you to work those 5 problems, and I want you to check your work with the key in the Unit 8 classwork folder. And then we're going to do a couple more problems. Okay, hopefully those review problems went okay, and we're going to just do 2 more problems together, and then we'll be all done. So this is saying sine of some angle is 1. And actually with this one, let's change this to a cosine. So could you just, so we're on page 4, number 1, change this to cosine of 2 theta equals 1, because the next one we're going to do is sine as well. So let's change this to cosine. Okay. So cosine of some angle is 1. So let's think about, where is cosine 1 on that unit circle? It's right here. Okay, so this is 0 radians. So what we can say is this angle, again, whatever this angle is equal to 0 plus 2 pi k. Again, where k is an element of the integers. Now, we don't need to write the 0 plus. We can just leave it as 2 pi k. I want you to find theta. So how do I do that? Well, it's double theta right now, so let's divide both sides by 2. And theta is pi k. So you're going to think about these problems exactly the way we've been doing the previous ones. This is just some angle. After you find out what that angle is, then you're going to solve for theta. Okay, and again, this is still with the k as an element of the integers. All right, last problem. Let's take a look at this one. 2 times sine of some angle, again, it's x over 3, but it's just an angle, equals -1. Isolate the sine function. Get that alone first. Okay, now, sine of something is negative 1/2. Here we are with our pi over 6, pi over 3, 90, and we have a half, and radical 3 over 2 and 1. We're thinking of our unit circle, and sine of any angle that is a negative output has to be in quadrant 3 or 4. Okay, so this is saying that, let's see, sine of something is negative 1/2. That means my reference angle is this pi over 6 again. This should look familiar to what we already did. 7/6 pi is here, and 11/6 pi is here. So you're going to tell me this angle, whatever the heck this is equivalent to 7/6 pi plus 2 pi k. And that angle, whoops, is also equal to 11/6 pi plus 2 pi k, where k is an element of the integers. Now, how do I get x alone? So this is ultimately what we want. We found out what the angle is equal to, right? We found out what x over 3 is equal to, that angle. But now we want to get what is x. So I'm going to multiply both sides by 3. So we're going to multiply by 3 here and 3 here. You're going to do the same thing here, times 3 times 3. Okay, so what does this get me? This is going to be 7, let's see, times 7/2 pi plus 6 pi k. And then this is going to be, if we multiply, we'll get 11/2. I'm just reducing the fraction, and you multiply, you get 33/6, which you can reduce, plus 6 pi k. This is the answer, the solution for x. Okay, we're going to definitely practice more. Make sure you're solid on those special right triangles, solid on those radians and the unit circle, and then we'll go ahead and dig in a little deeper during class.